Guys, welcome to my channel. If you're watching my channel first time, please subscribe my channel. So guys, in this video I'll be explaining about some of the important mathematical functions which are available in math library of Python. So for this I need to import math. So there are a lot of mathematical functions are available in Python math library. So approximately around 60 functions are available, and for a data science or for a statistical analysis, or maybe if you are doing some financial analysis, so all these functions plays very vital role in the analysis. So hence everyone must and should be familiar with this Python math library, which is inbuilt library in Python. So I am using Python, imported Python using import. Then first is like we'll discuss about rounding of the numbers. Okay, so rounding is very easy. So rounding means whenever we have a float data, now we want to round it into integer, so that is called rounding. So in Python directly we have a round function. For example, if I take x equal to, let me say, 3.1, then if I say y equal to round, so if I say round of x, then I will write print y. So now if I execute this program, then the number will be rounded up to 3. Okay, so actually input is 3.1 and its rounded is 3. Okay, after that if I take it as 3.5, so this is how the regular round function will work. It is 4, means after decimal point, if the value is from up to 4, means 3.1 rounded will be, round of number is equal to 3, 3.2 also 3, 3.3 also 3, 3.4 also 3. But once it goes to 5, from 3.5 it will be rounded to greatest integer. So this is called regular rounding. Okay, that was we happen. Now there is another way of rounding the numbers. So if you want to round numbers, like to highest integer or to least integer, then we can use floor and ceil functions which are available in this math library. So here what I will use is, for example, I'll use math dot floor. Okay, so this floor means it's a ground, right? So means it indicates the least bound, so lower bound. So 3.5 the lower bound, because 3.5 existing between number 3 and 4, so the least bound, lower bound is 3 and upper bound is 5. So floor always will round the number to its with respect to the lower bound. Now if I execute this, now you see the output will be 3. It is 3 only. Okay, now if I say here 3.9, still that will be rounded up to 3 only, because lower bound will be 3. And similarly if I put ceil here, okay, there is another way of rounding the numbers. Another function is, anyway I will write it like another program. So I will add one more code box. So here also I'll write for example x2 equal to let me say 3.1. now what I'll do is y2 equal to math dot ceil of x2, I want to count, and finally I would like to print, so print, here it is y2. Okay, so here x2 we took 3.1. now we want to ceiling. Ceil means it will round up the number with respect to its upper bound value. Okay, now 3.1 lies between 3 and 4 and its upper bound is 4, so the ceil of anything after 3 to 4 is, it will be 4. Now let me execute this. If I execute this, now it will be rounded up to 4. See, the answer is 4. Now if I use here 3.5 also, it will be rounded to 4. Now if I use 3.99 also, it will be rounded to 4. Okay, you can see its answer is 4. So like this, if you want to round up the numbers, then we can use floor and ceil functions. So floor function will help you in rounding the number to its least integer, and ceil function will help you in the rounding the numbers to its greatest integer. Okay, so this is how we can rounding up the numbers. So we have total 3 options. One is like regular round function, or floor function, or ceil function. Okay, then the other thing is that like square root. If you want to get a square root in Python, it's quite easy, because okay, so let us discuss about the square root of any number. For example, we can find out any real number. Let me take x equal to 3. Now we have I'll take here x3. So x3 equal to 3. Now I'll say y3 equal to math dot sqrt, square root. So the square root of it is x3. So then I will write here, so print y3. So now this gives me the square root of this number 3. So the input can be any real number, doesn't matter. Whenever you are calculating the square root, so the square root of 3 is 1.73, which is approximated up to lot of decimals. Okay, if I put 13 here, then the result will be like, so it cannot be perfect square root, no problem. So no need to give like, input as 4 or 16, something like that, because whenever you use such kind of numbers now, the square root is very perfect integer. No, it can be any real number, so you can pass any real number to square root function. So for example, if I say 133, now what is a 133? Approximately 11.53 it could be. Okay, if I give exactly 144, then it will give me like 12. So this is how this function will work. Square root function will have in this library. So what we have seen till now is floor function, ceil function, and square root function. Then one more function is there, like logarithmic function is there. Okay, so for example, let me take x4. So x4 equal to, let me take for example 2. Okay, now sorry, x4 equal to 2. Now what I'll take is, here I will say y4 equal to, I want to get the logarithmic value, so I'll say math dot log of x4. Now here, when coming to the logarithmic functions, no, the base plays a vital role, because it is very important what is the base for calculating the logarithm. Because generally when this, if you say log e, that is nothing but log of x4 with respect to the base e, that means it's a natural logarithm. Something generally in mathematics we will indicate like ln, natural logarithm. Okay, so if I didn't mention any base here, that will become natural logarithm of x4. So let me once execute it. If I execute, the answer is, it is 0.69. okay, so means natural logarithm of 2 is 0.69. Now what I do is, I will do it here, add 2. If I add 2 here, then that indicates it is a log of x4 with respect to base 2. Now x4 is 2, so log 2 base 2, it is actually 1. Any logarithmic value with respect to the same base, that will be 1. Okay, so now if you see, this is 1. Now if I put here something like a 10, so this will be log 10, so log of x4 with respect to the base 10 it is. Okay, now if I change this, again there will be a difference in the answer. Okay, so be careful while using this logarithmic function, because the output of a logarithmic function will depends upon with respect to which base value you are calculating the log function. You are using a log function. Okay, so like this we can use log function here. So in this particular thing. Okay, then other thing is that one more function is that we can get a factorial of any number. For example, if I say x5, so x5 equal to, let me say 5. Okay, so now I will say y5 equal to, so math dot factorial of x5. Okay, this is what now I would like to print the value of y5. If I print the value of y5, then if I execute this, see, factorial 5 factorial is 120. Every one of us know this. So which is nothing but 5 into 4 into 3 into 2 into 1. So this is how. Now if I say 0, because factorial 0 mathematically it is 1, 0 factorial it is 1. So now it is giving us this.